These techniques can be used to answer questions about resonance frequency, vibrational mode excitement, vibration amplitude, and how transducers with these characteristics perform as atomizers. With the information provided by these analyses, it's possible to rigorously quantify the effects of independent variables in experiments involving thickness mode transducers.
This technique enables the development of devices that can be used to atomize drugs for the treatment of respiratory diseases such as pneumonia. These methods are useful for characterizing atomization phenomena and can be applied to the study of capillary waves on the surface of a droplet.
Because many competing factors must be balanced, it can be difficult to achieve continuous atomization. Adjust the power input, wick position, and wick orientation, and observe how the behavior changes. Many of these techniques are simple to perform after demonstration, but require some dexterity and spatial awareness that do not come across in text.
To assemble a custom transducer holder, solder 2 surface mount spring contacts to each of 2 custom printed circuit boards, and clip the outer contacts so they do not short the circuit. Press fit the spikes into the plated holes on the custom boards such that the spikes point away from each other. Use board spacers and screws to connect the 2 custom circuit boards so the contacts are just in contact with each other. Adjust the spacing with plastic washers as necessary. Then slide a 3 by 10 mm transducer between the inner pair of contacts. To identify the resonance frequency by impedance analysis, connect a transducer to the open port of the network analyzer.